dear students, welcome back to 9th chemistry classes. In the last class we started a new chapter, that is atoms and molecules. In that class we discussed about law of chemical combination, that is law of constant proportion, and about conservation of mass. Then we discussed about Dalton's atomic theory. Hope both the topics are clear for you. Today we will discuss about atoms, atomic radii, and about the symbol of different atoms. So let's start. The first question that arises is, what is an atom? Okay, the definition or what is an atom? An atom is what simply we can say it is the building blocks of all matter are atoms. We already studied what Dalton told. When we go on dividing matter, a stage will be reached when we cannot further divide it, and that state he called it as atoms, isn't it? Atom is it is the building blocks of all matter. Okay, matter is something that has volume and space. The building blocks of a matter or the basic constituent of a matter is atoms. Okay, the smallest constituent unit of ordinary matter that constitute a chemical reaction is known as an atom. It is the smallest constituent unit of an ordinary matter that constitute a chemical element. Is another definition that we can give to an atom. Atoms are extremely small. The next question that arises is, how bigger or how smaller is an atom? So let's discuss about the size of an atom. Okay, atomic size can be explained with the help of the term atomic radii. Usually we define atomic size, that means the size of the atom, with the term atomic radii. So atomic radii is the expression of atomic size. Okay, we can express the size of an atom. Okay, the size of an atom can be expressed in terms of atomic radii. Atomic radii is measured in nanometers. Okay, as I already told you, what atoms are very extremely small. Very small. We cannot even imagine the size. Okay, that means millions of atoms combine to form a sheet of paper. Okay, millions of atoms, they combine to form a sheet, or a single sheet of paper contains millions of atoms. So we can't imagine what is the size of an atom. That much small is an atom. Usually atomic radii is used to express the size of an atom, and it is measured in nanometers. This is the unit of atomic radii, nanometers, like centimeter, meter, etc. Nanometer is a unit. That is 1 by 10 raised to 9 meter is what? 1 nanometer. Children, 1 by 10 raised to 9 meter is 1 nanometer. Okay, and so 1 meter is equal to what? 1 meter is equal to 10 power 9 nanometer. Clear? 1 by 10 power 9 meter is what? 1 nanometer, and 1 meter is 10 power 9 nanometer. Let's compare the relative sizes of certain substances or certain atoms to know to compare the sizes. How much is the size difference? Or to just get an idea about the size of the atom, let's compare the relative sizes of some of the substances. First look, an ant. Okay, an ant, if it is having a size of 10 power minus 2 meter, that means 0.2 positions here, isn't it? 0.1. If it is 0.1 is the size of an ant, just a comparison, okay, a grain of sand will be having 10 power minus 4 meter. That means that much zeros behind. 10 power minus 4 meter. Then a molecule of hemoglobin. What is a hemoglobin? This is the red pigment in our blood, isn't it? And the molecule of hemoglobin has what? The relative size or the radii. Atomic radii here is what? 10 power minus 8. The radii in meter is given as the value, okay, or the atomic size we can say, size or the radii is given. For a molecule of hemoglobin, the relative size is 10 power minus 8 meter. And for a molecule of water molecule means hydrogen atom and oxygen atom combined to form a water molecule. It has a relative size of 10 power minus 9 meter. Then an atom of hydrogen has 10 power minus 10 meter. This is the size. 10 power minus 10 means 10 zeros in the backward, isn't it? That much small, extremely small size is the atom of a hydrogen. So this data is given to just compare the sizes of different items to understand or to get a concept of how much small is an atom. But now today we have different scientific methods or the certain instruments to understand or to get the magnified image of an atom. There are now many instruments, okay, to find the sizes of an atom, or you will get what the surface of atoms. How is it looking like? We can identify from the images through certain microscopes, or certain techniques are available to understand the size or the surface of atoms. Symbols are a representation of atoms, isn't it? We use symbols for the representation of atom. So earlier it was John Dalton was the first scientist who introduced or who used certain symbols to represent atoms or elements. John Dalton was the first scientist who introduced symbols. Okay, he used symbols for the sense that an atom of the element, okay, each symbol represent an atom of the element. This is how he used the symbols. Each symbol will represent an atom of that element, okay. The first symbol is that of a hydrogen. A circle with a dot in the center is the symbol that he introduced for hydrogen. Next, for carbon, this is a circle, that is a colored circle was for carbon. Just simply a circle is for oxygen. Then this symbol is for the phosphorus atom or phosphorus element, okay, for the phosphorus atom. Next, a circle with a plus sign inside for sulfur, a circle with an I symbol inside for iron, a circle with C for copper, circle with L for lead, and a circle with S for silver. These are the symbols that he used. Next, for gold, a circle with G at the center and also certain lines at the circumference of the circle. Next, P for platinum. Now we use the term platinum, isn't it? P with a circle is for platina, the symbol used, and for mercury a circle with circles inside, small circles inside, was a symbol that John Dalton used for representation of an atom of an element. Study all the symbols. These were the first symbols that were developed by the scientist John Dalton. After Dalton, it was Berzelius, scientist, who told that symbols of elements can be made from what? 1 or 2 letters of the name of the element. Symbols can be taken from 1 or 2 letters of a name of the element, was the suggestion by scientist Berzelius. Before that, in the beginning itself, what? Names of elements, okay, not symbols of element, names of elements were derived from the name of place of origin of the element, from the place where the what elements were derived, the name of that were taken as the name of the element. For example, copper taken from the place named Cyprus, okay. Names of the elements were derived from name of the place of origin of the element. From where the element originated, names of the elements were taken from that place of origin. Example is copper taken from Cyprus. Also, names of elements were also taken from specific colors name. Okay, color of the element will be given to the given as the name of the element also. For example, gold was taken from the English word that means yellow. Gold is taken from the English word that means yellow. From the color of the substance also names were taken, and also from the place of origin of the element, the name of the element were taken. It was Berzelius then who told what symbols of the elements can be derived from the name of the elements. First or two letters of the name of the element can be taken as a symbol of for a certain element or for a certain atom. In the present situation, it is IUPAC. Okay, IUPAC. It is an international union. International Union of Pure and Applied Chemistry. It is a board or it is an international union of pure and applied chemistry. That union approves the names of elements. In the present situation or nowadays, IUPAC, International Union of Pure and Applied Chemistry, is a union that approves the names of elements. There are certain rules for approval or rules for giving names to the elements. There are certain rules for giving names to the elements. The first rule is the first letter of a symbol is always written as a capital letter or in the uppercase. Okay, the first letter of a symbol will be always a capital letter and the second letter is small letter or a lower case. Always the name of an element starting will be the capital letter or the uppercase and the second letter will be a small letter. Example, for hydrogen, only H, it will be capital letter. But for aluminium, we already know that it is not a L, isn't it? It is a small letter L. That is the representation of aluminium. For cobalt it is what? Capital C, small letter O and not CO. This is wrong. Okay, the first letter will be a capital letter and the second letter will be the small letter is the first rule. The second rule is the symbols of some of the other elements. Okay, certain elements are given with the first letter of the element and also second letter will be the small letter of that element. Then the second rule is what? Symbols of the other elements formed from the first letter of the name. From the name of the element, first letter is taken and the second letter will be appearing later in the name, not the second letter of the name of the element. The simple first letter is taken from the first letter of the element and the second letter will be a letter that is appearing later in the name of the element. For example, consider chlorine. The symbol is not CH, isn't it? The symbol is CL. C capital letter and L will be always small letter. This is the first rule. First letter will be a capital letter and the second letter will be the small letter. Here zinc. The symbol is not ZI, it is ZN. Zinc is represented by the symbol ZN. That is a letter that is appearing later in the name of the element. And also chlorine, CL is the representation of chlorine and for zinc it is capital ZN are the symbol of both the elements. The third rule is other symbols. Okay, other symbols of the elements are taken from the names of elements in their Latin, German or Greek. Okay, the meaning of the elements will be in the Latin, German or Greek word. That symbols were taken as a symbols. Okay, for example, for iron, the symbol is for Fe. Okay, the symbol of iron is Fe. That is taken from ferrum, which is a Latin word. Okay, the Latin word for iron is ferrum. And the name or the symbol for this iron is taken from this Latin word. The first two letters of that Latin word is Fe. That is a symbol of iron. Okay, sodium is known in Latin as natrium, Natrium. So, the symbol is Na, taken from the Latin word of the element. Na for sodium. Similarly, for potassium also, the Latin word is kalium. For potassium, the Latin word is kalium. So, the symbol is what? K. For iron, from the Latin word ferrum, so the symbol is Fe. For sodium, from the Latin word natrium, the symbol is Na. And for potassium, from the kalium, and the symbol is K. Okay, some of the symbols of the elements were taken from their Latin or Greek words. So, from these rules you understood that each element has what? A symbol for representation. Each chemical element has a symbol for the representation and they has a characteristic name. Now let's discuss the symbols of certain important elements. Okay, now first element is what? Aluminium, represented by Al. This is the symbol of aluminium, Al. For argon it is Ar. Okay, argon by Ar. Barium with what? Ba is the representation of barium. For boron it is B. Okay, for boron the representation is B and for barium it is Ba. Remember, okay. For bromine it is Br. Bromine it is Br, boron B and for barium Ba. For calcium it is Ca. For carbon C. For chlorine it is Cl and for cobalt Co. Okay. Calcium it is Ca, carbon C, chlorine it is Cl and for cobalt it is Co. These are the symbols of these elements. Next for copper. For copper it is Cu. Okay, for cobalt Co, for copper Cu. For fluorine it is F. For fluorine F. For gold Au. Au is the symbol of gold. For hydrogen it is H. For iodine it is I. For iron, ferrum, it is originated, isn't it? It is Fe, iron. For lead it is Pb, capital P, small letter B. Magnesium, it is Mg. Okay, for magnesium it is Mg and for neon it is what? Ne. For neon, capital letter Ne. These are the symbols, important symbols of some of the elements. The next element is nitrogen. Nitrogen represented by N. Oxygen by O. Okay, element oxygen by O. Potassium we already studied from kalium. It is derived from the Latin word, so it is K. For silicon it is Si. For silicon Si. For silver it is A, capital letter Ag. Capital letter Ag for silver. For sodium we already studied, it is Na. And for sulfur it is S. Look here, for silicon it is Si. Sodium Na. For sulfur it is only S. For uranium it is U, capital letter U. And for zinc it is what? Zn. Okay, these are the representation of some of the important elements. You should study the symbols of these elements. It is very important. So dear students, in today's class we discussed about atom, atomic radii or the atomic size of atoms and its unit in nanometers we discussed. Then we discussed about the symbols. Earlier it was Dalton who first developed the concept of symbols. Then came Berzelius and at last the International Union of Pure and Applied Chemistry used to approve what? The name of the elements. We studied some of the symbols of the elements and you should study that. I hope it's clear for you. If you are having any doubt, you can comment below. Thank you and have a nice day.